I will do a very quick introduction. Rich is a co-founder and architect of Redline 13. Eldad is an automation engineer at Merck Animal Health Intelligence Technology Labs. And David Milette is the founder of SQALogic, which is a global network of industry experts and thought leaders. So let's jump right in here to some questions, and I'm going to ask the audience to please in chat go in and let us know what you would like to hear from. So the overall topic is kind of what is the future of load testing, which is that's easier said than done. But so I'll throw out the first question. In what ways will load testing in the future be harder than it is today? And let's start with Rich.
I think that so kind of two parts to it. One, the future, and what I talked about earlier relative to these new type of apps in Web3. I think that is harder. I think there's a lot of unknowns there, and different dynamic than we're used to. Where in the old days we used to, you would talk about performance testing. 20 years ago, and you would say, oh, look at this, pre-iPhone, we were still doing mobile development, and you'd have to worry about bytes. Same thing you felt like when desktops first came out, or you were an early coder in the 80s. I mean, you were worried about like 64 kilobytes was a lot. And I think that always changes. The goalpost there kind of changes all the time. Cloud, AWS and the cloud has changed a lot of that in terms of scale, but it kind of always happens, right? So we look at what's going on in Web3 and say, oh, it's the gas price. It's this distributed part. Ethereum can't, Bitcoin can only do X transactions. Ethereum could do more. But the goal line is always moving. So, I think it's a challenge, but it's a challenge that the future just keeps moving the line for.
Okay. Eldad, your thoughts?
If you went back to the 80s, and I know it's a good place to start. Now, again, I said that in my presentation. I'm going to say it again. The 80s is 40 years ago, not 20 years ago. Many people find it hard to believe. Yeah. But if you went back to the 80s and let's say you started working on an application and you had two developers working on competing applications. One developer is a hardcore, is going to do whatever it takes to get, like an extra 10% better performance. He's going to allocate the memory better. They're going to do all sorts of manipulations to get their application running faster. And the other developer is lazy. He's going to the beach drinking mojitos all day. And he's just waiting for better hardware to come up. So better hardware to run faster. So back in the 80s, this second lazy developer would win because in a few months, you're going to have new hardware that is going to be better. But that's not the case anymore. Now we really reach this diminishing return that, better hardware comes up, but it's not significantly faster. So you're not going to win by drinking mojitos on the beach every day, unfortunately. If you like Rovarzi, I like it better, but whatever you like. So the real problem is, I think one of the main problems is, the diminishing return that you get from platforms. You can't rely indefinitely on more resources. At some point, you're going to be forced to make a better use of the resources you have. Now, the difficulties that it makes on performance testing is that performance engineers would have to be very involved. And not only, it's not like I'm a performance tester, I run the test, they failed, now deal with it. But the performance engineer would have to be very involved in the investigation and also with finding solutions, even if it's not in their direct realm of expertise, the DevOps or the development itself. But they would have to take part, and the more proficient you are, in different areas, the better value you could get to your organization by being more involved in these processes.
All right, great. And finally, David, I mean, you're working with a lot of different clients and these kinds of things. What's your thoughts?
Yeah, so we've definitely seen some significant trend changes from actually even the whole notion of what people are doing. So people in the last again, I would say 20, but I guess it's 40 years. Darn, it goes so fast. But I would say that for the longest time it was all about load testing, right? People were testing the load on the application, and often it came late in the game. The thought about load testing came right before we throw it into production, or after something goes wrong in production and you want to find root causes and so forth. It wasn't something that was often blended into the project itself. So what we're seeing in the last, I'd say, year or so, probably 2 years, give or take, is there's a trend towards performance engineering versus performance testing. So, the performance is now something that's embedded into the definition of done of projects. It's something that is thought more and more in the optics of what you're developing with targets that need to be attained. So it's no longer just an afterthought of we must do a test to attain these goals. Every single piece of an application that's being built, the performance of that piece is thought, and the testing around that is being done. And what that means is the complexity of the testing is actually going up. I find that you find performance tests that'll start earlier in the game that'll run throughout the whole project. You'll have performance gateways that are set up in your Jenkins systems or whatever that may be that are driving your CI/CD and pushes into production, where gates will just stop if performance isn't attained. And this is a big leap, I'd say, from a maturity perspective on the way it's being looked at and treated. And it also, is something that I find very cool and exciting for people that are in the performance testing field. If we look more at the technical side of it, right, more of the challenges that are faced, we're dealing with more and more, microservices applications. We're also dealing where, performance testing was often you send a transaction out and then you wait for a response to come back, and that was your response time that mattered. But in the new systems that actually talk with multiple different angles, and an answer can go out to a third-party system over there, and that matters to you, right? You need the time, what it takes to get over there, not just the round trip. There's a complexity in the logic of how we have to think of what is real good performance within an application. It's not sometimes just the round trip. It involves also time that it takes to send off certain activities to other areas, and how do we correlate that back when we look at the actual end results. So there's a complexity that's happening with these multi-tiered, multi-communication systems when you're looking at what performance is. And again, that's engineered into the way you think about performance in those applications.
Okay. I've got a bunch of questions, but that I'm very interested in hearing about, and I will ask again the audience. Now's the time to enter. Start writing in your questions. So we talked about some of the challenges and how things are in some ways going to get more difficult. Are there any ways that things are going to be, should we say, easier than they are today? We'll go in the same order. Rich, you want to start there?
Easier. I think David and Eldad both kind of alluded towards. There's always eking, the details, and I'm not sure the details always get easier. That's kind of part of figuring out performance engineering and figuring that out. And as the challenges get more interesting, then there's more to do there. So I don't know what gets easier. I think there's the tooling increases. I think there's eventually more ties between the data that comes out in production environments, more things that can correlate, or some of the AI that's coming that might help point in the right direction to figure things out. I think those things are emerging. I think Eldad's been writing stuff around machine learning and testing that. So those are like new technology, new ways to test. Very interesting stuff. If anybody hasn't read it, we're just going to promote it because it's actually really good. And that stuff will help. It just kind of couples the process.
All right. Same order, Eldad?
Yeah, well, AI and testing goes in both directions. One direction is how you test machine learning-based systems, and the other way around is how machine learning can help you test your own systems. So it's kind of but goes both ways. So I think we start to see more tools that involve AI in fine-tuning your Kubernetes your Kubernetes infrastructure. So you need to fine-tune just about how much CPU or what kind of constellation of pods you need for a certain environment. So you start to see more tools in the fine-tuning department. But again, testing. I mean, I don't think there is a lot of applications out there that don't have some machine learning components, and machine learning components can sometimes be a performance bottleneck because data scientists or AI scientists are not particularly good at high performant. Sorry for all my folks at the data science, but they're not usually as proficient as for example, your backend developers in creating high performant applications. So they could be a bottleneck in many situations, and it needs to be addressed.
All right, David.
Yeah, I would say I agree fully with both Rich and Eldad on that. But what I find is what we're looking at as well is the a round robin sort of model to again performance engineering, right? Performance testing is often like we have a milestone or something or a go live and we run a load test against it and we optimize. But what we're seeing more and more is bringing the production data in to better estimate what we should be testing. What are the mix of transactions? What are the things we should be looking at, right? That's often a lot of guesswork, right? And we use our experts hats and we try to guess what are the key transactions, but more and more, I think we're gonna see over the next couple of years using AI, using analytics and things, the capacity to bring in and say, hey, 80% of your load is coming from these 5 transactions. You need them. Your data needs to come from there. These types of things need to be looked at. And those types of elements are going to facilitate the work for the performance engineer to make sure that the load testing is extremely representative of the reality in production, right? And that's important because if you don't you can run a great load test with extreme load, but if it doesn't represent what's actually happening on the field, it's an invalid load test. It won't give you the results that you want. So I think we're going to see those types of things. And I would add to that the fact that we're talking about some of the complexity and things that happen. I would say that one of the things that people are testing more that actually adds a kind of a nuance to things is more and more people are deploying their applications into the cloud, private cloud, public cloud type environments. And these cloud environments, right, which Redline actually leverages to generate the load, which is great, right? But these cloud environments, what they have often is the capacity of dynamic scaling, using algorithms and AI to scale up and add CPU and add memory and add bandwidth accordingly to what it's seeing as a load that's being generated. So not only do you have to test your application against the limits of a physical machine now, you got to test and take into consideration how fast is that scalability to work? Is it operating correctly? Is it oversizing me and charging me too much now because it's adding too fast or not enough and it's impacting me to lose transactions to my customers that I'm trying to sell to? So I think above and beyond, like we used to look at it as let's test the limits of the box, but since the box can now expand, right, and can grow dynamically, we got to test that capacity of expansion and what are the impacts of it. So it's a sort of another angle to add into the scope of performance testing when we're doing that.
All right.
If may I extend on what David talked about, he said that you need to bring your production into the load testing environment and test it. I think it's even worse than that. You need to forecast how your production will look like in about 2, 3, 4, 5 months from now. You kind of have to play Nostradamus now to forecast the future. And then you have to bring it back to your load testing environment and slam it and see how performant it is, or how well you're going to. You need this breathing window. It's very often you need a breathing window. You're like, okay, my current infrastructure is going to hold for like 2, 3, or 4 months. So I have 3, 4 to 4 months to plan the next thing, so it will be better, or hopefully better. So it's a lot more difficult than that. You have to really forecast the future, and you have to use good analytics for that.
All right. So let's take a step back here. So if you look at your load testing experience, and between the three of you, you guys have obviously a lot of years in this. what's one or two things that have surprised you about this kind of load testing journey that you've gone on? So let's flip it around, David. Why don't you start here?
I'd say what I find interesting when I look at, I've been doing this now for 25 years or so, actively engaged on load testing, on a year-to-year basis. And I think what I find interesting is testing is cyclical, right? And what I mean by that is for a series of years, you'll see the emphasis of organizations is put on functional optimization and code coverage and things of that nature. And then all of a sudden there's a cycle that'll come in and performance will be the big thing for a number of years. And to what Eldad was mentioning, I think it goes a lot around the lines of availability of a buffer from a performance perspective that you have. When the cost of memory was extremely high, right? And every little optimization mattered. Of a memory leak of a little bit could have a big impact. Everybody was about performing load tests and finding, when we ran 10,000 times this transaction, this little memory leak caused this system to crash, right? That was okay, we got to get the code fixed in that area. And those types of tests were very big because the cost of that memory was extremely expensive. And then all of a sudden, cost of memory went down. It was easier to just drop an additional 16 gig in there and, forget about it, reboot it once a week type of thing. And as that, CPU, memory, network bandwidth, things like that, all impact the way people think about performance, right? And the fact that we're hitting that plateau kind of where, there's improvements, right? But for the cost that it costs to get to the next level in improvement, it's no longer you double and triple the performance every time. We're seeing this return back to performance testing. So what I'd say is, my observation that I came to this year is that cyclicality of the importance that are put on different aspects of testing. And my analysis is I think that there's a direct correlation to that aspect of cost and where the organization can get savings, right? Because nobody wants to do QA just to do QA. You do it because you want to release a quality product to your customers, right? But you want that to be done at the most cost efficient way possible. So that calculation is always in the back of the executives that make the decisions on where they spend the money and where they put the time and dollars to do things. So yeah.
Eldad?
I think that the ability to empathize with your customers. Every time you jump into some government website and you get frustrated for how long it takes to load. So empathize with your customer, because this is what they will feel when they use your applications and they're not performant enough to serve them on time. And maybe it's not as urgent as, I don't know, paying your taxes, but it could be urgent enough for some people. So empathize with your customers. Remember, you represent your customers. You're the last line of defense to those people who actually pay for your services. So this one mantra has to be kept in your mind all the time when you do tests. And I think that you don't do QA just to do QA. That's exactly the point I brought up in the presentation about being cooperative and being competitive at the same time. You have to be competitive because you need to represent those customers. And those customers should not have bad experience just because you want to give people the answer they want to hear, or you want to avoid confrontations. You have to go with it and make sure that you deliver the highest quality you can.
All right. And Rich?
And the tax sites still have issues, and they still go down when things happen. So yeah, I agree with you about empathy and using that as a way to understand and to Dave's point, help prioritize what you work on. I think surprised me is that we still I'll give two pieces. We still miss details. So a recent load test that someone ran, they tested the endpoint and their API worked fine, but they really didn't test. And this is kind of to Eldad's point about analytics and understanding and projecting. They didn't really project, well, if people use this feature and we have more data, what's the load test going to look like at 100 items, 1,000 items, 10,000 items? And they quickly got to a few thousand items and performance slowed down, and because they didn't really test the scenarios that they should have. And so even though they did, it's kind of like you still need to understand and think through the use cases and understand what your customers are doing, And the other one, and that we see from Redline, I guess it's somewhat still surprising that people come afterwards. They load test after the fact. We just launched, and we had 5 users on it, and it's not really running well. Can you help us figure this out now? And then a lot of people come with no performance engineers, and it's QA folks or the team. And like I said earlier, they just want to take their Selenium test and run it at 1,000 or something like that. But we still see people coming after the fact and not putting it in their plans.
Okay.
Yeah, there is a very cool experiment that they typically do in groups. They're like, imagine an organization. They divide it into groups, and each group takes a bunch of wood sticks, like the wood sticks of a snow coat, and a piece of marshmallow and duct tape. So, and then they need to build the highest building they can with the marshmallow at the top. And always when they put the marshmallow at the top, everything crashes. So I think the marshmallow is the performance testing. The performance engineering is that marshmallow that you always do at the end, and then everything crashes.
Yeah.
All right. So reminder, if you want to ask a question, now's your opportunity. I will keep going otherwise. All right. So what do the current load testing frameworks not have? And I'll start with Rich on this one.
What do load testing frameworks do not have? What features?
Yeah.
I think there's kind of this wide range now of different frameworks doing different things, and so they have things like JMeter, which has been around for a very long time, but really, and it has the core of load testing. It has the UI, but doesn't really have the developer friendly language. Then you have things like K6, very built on more very current or Locust, and that are more focused purely on dev, but don't have a way for QA to get involved because it's less user interface driven to build a load test or manage them. So I see this piece in between that pieces don't have. And then I think that Dave mentioned it earlier, none of them are yet truly integrated into your production environments. They're still thought of, to Eldad's point, of the marshmallow. We do it at the end, and we still don't do it. It's not integrated into production. And one of the things, and Dave and I have private talks about this, is like how does load testing really integrate into production? How am I looking and comparing the results from these tests to what's going on in prod in near real time or something along those lines to kind of get better at predictive? So I think that's, for me, some of the kind of futuresque kind of thought process on features, but not like day to day.
All right. David, you want to add to that?
Yeah, well, again, as I said, and as Rich just reiterated, I think that ability to bring in that data from production and leverage it as an established baseline, and then adding in the analytics around what you're projecting as far as growth and things like that to be able to establish performance boundaries. And then, I'd add even onto that is an ability to have the stakeholders that are key to performance be able to add in what matters to them and leverage that as gates, right? So from a business user perspective, what are the response times that they want to see? From a performance perspective in the back, what are the metrics that we want to be gearing for, right? As far as different elements of cost or things of that nature, so that what happens is, I think that if we had the ability to sort of embed that into the load test prior to it running, and then come back with it passed or failed across all these different stakeholders' requirements, we could automate that process and remove some of that guesswork and work that needs to be done to figure out if the results that we have are good or bad, right? So from a business user's perspective. So
Eldad, anything more to add there?
I think that very often it's something that David mentioned earlier, that it's no longer the round trip that matters, it's everything that in between, and you have a lot of asynchronous stuff that's going on all the time. So even if you have a round trip of, say, 200 milliseconds, But then after that round trip, you have more processes that can take 2, 3, 4 seconds. So you have like a, like a 10 times fold more time spending on background stuff. So I think that more integration with databases to preserve some states, and then you can analyze it on your own. Today, I'm doing everything after the fact. So let's say I slam the system, and then I download all the logs from Redline 13, for example. I download all the logs, I parse them, and then I square that up against logs from the production or the system under test. And then I create matrices and all kinds of analytics. I think that we can see more live streaming of such data so that we can analyze it while it's running and not after the fact. I think there is a good plugin for InfluxDB in Redline 13. I haven't tested that yet. I really want to do that, but unfortunately, there's only 24 hours a day, and that's 24 hours too short. But I really want to see how I can really do this end to end, and if I will be able to do that, if I'm able to do that, I can give my developers an awesome experience that they can literally see this analytics while running. So I think that part is quite missing, but not for long. I think we start to see it popping out very quickly.
Okay. All right. We have a question here, which I'm going to, from the audience, and I'm going to show that. Eldad, do you want to jump in on that first?
Yeah, I think it's crucially important. Of course, you can have it both ways. You can sometimes say, I'm going to have some fixed numbers of scale that I'm going to slam and see if it works. And then you could try a more flexible environment with auto scale groups and stuff like that. And it is important because it is a feature. Infrastructural features are features for all intents and purposes, even if your customer are not aware of them. Even if your customer doesn't know how many pods you spin up, it doesn't know and he doesn't care. But it is a feature. It is a feature that you support, and it should be tested. It should be accounted for, and it's part of this growing ecosystem of test ops or dev test ops. I'm trying to get this into my organization that we are testing the infrastructure, not only the code. Okay, remember, you're not shipping code; you're shipping features, and the features are to be tested.
David?
Yeah, exactly. I brought this up earlier a bit as well, right? The whole notion of scalable environments changes a bit the way that we need to look at testing. And as that mentioned, it is a feature. And I think there's two key areas that are going to be added into the scope of definition of done and definition of ready and things of that nature in the products that are being driven. It's security and performance, right? These things shouldn't be afterthoughts. They need to be thought of the application and experience to the customer that you're delivering. So you need to establish and include those elements in there.
All right. And Rich, I'll give you the final word here.
I really do think Eldad kind of covered it. It's from a practical and reality perspective. The challenge I have seen is it comes down to, and it's not the load testing fault, it's just the budget fault, and depending on the scale you're at. So I've managed organizations from 10 to 200, and as we scale, there's a lot more. The budget grows with that, and I think kind of also Dave had kind of talked about where do people spend their money and their budget in different pieces. So I think that to me that has been the challenge. It's never been should you. The answer is always yes. And should you do it at scale? Yes, because you have to validate. You want to empathize to your customers. You want to know what your load's going to be, and you want to be able to achieve that. Which means, if you have a scaling environment, you should be testing that. I think it was in Eldad's presentation on the smells and stuff like that. It's a no-brainer, but it does come down to manage. There's a secondary part to it, which is managing cost.
Yeah, in other words, desires are infinite, resources are finite.
Yeah, yes. Good work saying it.
All right. Well, that we are at the end of the event here. I want to thank the three of you for being part of our panel discussion today. So I am going to just wrap things up and thank the audience here. Rich, I don't know if you want to hang around for that, or otherwise I will remove you guys from the stage.
Thank you, everyone. Thanks,
Thank
everyone,
you.
for attending and for everybody who presented.